Hello everyone and welcome back to Post Network Academy. I am Bindeshwar and in this video we will explore linear regression and how it learns from data using a powerful technique called gradient descent. So let's break it down step by step with math, Python and even animation. So without further delay, let's get started. So we have a collection of labeled examples. Xi is a d-dimensional feature vector, for example I, and y is a real valued target output. And each feature, that is a real number where j vary from 1 to d. So we will build a model, that is fwb, which will have two parameters w and b. W is weight and b sometimes called bias. So basically this is a linear function, so that's why it is called linear regression. Here w is a d-dimensional vector of parameters and b is a real valued bias term. Then the model f is parameterized by w and b. Now let us see sample data set. A company is spending this amount of money and its sales are like this one, 37.8, so sales 22.1, 39.3, so 10.4, and we will establish a relationship after finding w and b. That is the task of a linear regression. That means based on this data we will approximate a function fx wx plus b. So what does approximation mean? We have to find w and b. Then we will have a function, and see that this is the almost in every algorithm a model learns a function, whether it is deep learning, generative AI, or machine learning, or any algorithm. It learns or it approximates a function. Now goal is to predict sales based on spending, what I have already explained. Now model we have fx, that is wx plus b. Learn optimal w and b from training data. We can learn many values, but optimal values. Optimal means error would be 0, prediction error, and value of cost function would be 0, and we will minimize mean squared error. Now what is the mean squared error? So here L loss function 1 upon n, this is the actual value minus predicted value square. Now what does gradient descent algorithm do? So we will update w and b using gradient descent. So first of all we will derive, or you can say that we will take derivative of loss function with respect to w. That means if we change w and b, loss function will increase or decrease. So loss function is function of loss function, or cost function is function of parameters. So wl upon deva l upon deva w, because partial, because a loss function is function of w as well as b, and when we differentiate or take derivative, so we will have this term. The same way for a b we will have this term. Now use the gradient descent to update. So we will update like this one. So new w old w minus alpha, that is a learning rate, and this part loss function, or you can write in the same way like this one. Minus will come here and thereafter it will come here, so that would be plus. Thereafter b update rule, the same way, the new one older one, there is a learning rate and this is the loss function. So we will update the value of parameters and we will simplify and we can get this one. Now we will import libraries to implement it. Matplotlib, pyplot for plotting, animation for creating dynamic plots, also spending data x and corresponding cells y. So 15 data points I have taken for a linear regression, and goal is to predict cells from spending using a linear model. So first of all, weights would be initialized. You have to initialize. So you will take W0 and B0. Thereafter, learning rate alpha, that is 0.0005. You can increase or decrease. Epochs 100 iterations. Will save history of parameters and loss for animation. So we will predict y hat, where loss function or cost function is MSE, mean squared error. Thereafter we'll compute gradients, that means with respect to loss function, because loss function is function of parameters. We will update w and b both. So we will have two subplots. I will show you, and also animation function, so that you will understand using func animation from matplotlib. So key takeaways, I will show you the Python code and I will also run, but gradient descent is iterative or improves model parameters gradually. Animation helps visualize model fitting and error reduction, that is useful for teaching machine learning concept effectively and efficiently. Now let us see the code, that is very important. So code here libraries I have imported NumPy, Matplotlib and PIL, and datasets 15 dataset we have taken, that is X and that is Y. X is spending, Y cells. WB parameters initialize, alpha, that is learning rate, number of epochs, that means the same data set how many times you will pass to the model. Length of x, history you will store. Thereafter here is the training loop, that is the most important here, till here, that is the training loop, that is the most important. You should understand, this is the training loop. So y prediction, loss will measure, thereafter gradients will be computed, thereafter update, and that would be appended here. Otherwise these are for plots. This is the most important part of this code, training loop here. Now let us run and see the result. So you can see that here also plot. Here I'm trying to resize it. So just see that is a GIF file, GIF file, so there will not be problems. And here again you can see that, and x-axis spending, y-axis sales unit, and this is the regression line. And this loss over epochs means the number of epochs are increasing, loss is decreasing, and this line is being fitted. Now as I told you what you will get, so here W you will get, you can see that here in the final W is 0.4318 and B is minus 0.0072. So finally I can write that model 1 like fx w, let us see again. So 43 I can write 0.43 x plus, that is the w, and this one plus here minus 0.0072, that is b. So finally what will we get? Regression line fx 0.43 plus that is x minus 0.0072. So that is the regression line that fits the data. So hope you understood. For a more post you can visit www.postnetwork.co, YouTube channel, Facebook page you can visit, a LinkedIn page, and GitHub repositories for the code. So hope you understood. Thanks for watching the video.